So, like I spoke about before, we're taking a look at strategies for heat recovery. So we're going to take a specific look at the two pipe versus three pipe systems. Um, Out in the field today, everybody knows there is heat pump with VRF and there's heat recovery. So all heat pump systems are two pipe systems. So heat pump is where you're not simultaneously heating or cooling. And this is from a commercial standpoint only is what I'm discussing, not necessarily the residential side. So you have the heat pump and then you have heat recovery. And the manufacturers who do two pipe in the United States today, you're gonna have Mitsubishi, and then you're gonna have the Carrier Medea product. So those are two that utilize the two pipe system where Samsung, LG, Daikin, Fujitsu, everybody else uses a three pipe when it comes to the heat recovery side. So we're going to take a look at the differences between those. So we'll take a look at heat recovery concepts, just the overview really of the strategies. What are you looking at when you're in a design, and what are kind of the positives and benefits of each design, whether it be a two pipe or a three pipe system. We'll take a look at the piping and materials, the equipment footprint. And you might be saying, okay, why is that important? Well, a lot of project costs as well are dependent upon how quickly that mechanical contractor can get off the job. So you'll see in some of the examples later on that we use, we show an example where a three pipe system is actually easier to install, a significant amount of less piping, and then also a two pipe system where it is a significant amount of piping that is shorter, and it would get the contractor off the job quicker. So these are some of the things you want to think about, not only on delivering a system that is fully functional as well. We'll take a look at the heating capacity. You are going to see a little bit of a heating capacity increase on a three pipe system because it is an independent hot gas line. Then we'll take a look at application revisions. So anytime you do a VRF project, the mechanical contractor has to do an as-built design. So originally we put an estimate into any manufacturer's design tools, and we take a look at how much additional refrigerant charge is going to be needed to charge that system properly once it's installed. So before the job is done, this is estimated by taking, I believe Rod uses Bluebeam to manage the feet of piping on each independent system. We put that in, and then when the job is actually installed, the contractor lets us know, hey, we were able to do the 30 feet and 4 bins schedule between this section, or they let us know, hey, we had to go to 45 and it went to 8 bins. This is important because we have to do an as-built design drawing from every manufacturer so that you can get the correct amount of refrigerant piped in that system. The reason we're also going to take a look at this is how sometimes shortening or longing a certain piping section can affect two and three pipe systems differently, and actually called field revisions. But we do have a real live example of a project that this happened on that we're going to take a quick review at. Then we'll wrap up. You guys will be able to ask any questions that you guys have for me. And like I said, if you have something now in the moment, please don't hesitate to reach out or to just throw your hand up in the middle. We can discuss it then as well. So like we talked about, heat recovery is just a variable refrigerant flow concept, essentially. So you've got simultaneously heating and cooling, and you're going to have three pipes on three pipe systems, only from the condensing unit to the BC controller, the branch selector box, or the mode change unit. Every manufacturer uses a little bit different term versus it, but they're all in all, they're utilized the same. What is the difference between a two pipe and three pipe BC controller or MCU controller? A lot of people aren't aware of what the differences between those are and how that can affect installation costs as well. So we'll touch on that too. So the heat recovery technology is just like we've talked about. You use BC control to be able to simultaneously heat and cool. Want to touch one more time that the three pipes are only from the condensing unit to the BC or MCU, and then from the BC controller or the MCU controller to the indoor unit is always two pipes for every manufacturer. So how does the heat recovery process work on a three pipe system? So we're recovering that waste heat. For example, you see down here in the bottom left, this is indoor unit is in heating mode. So you're sending hot gas to that indoor unit. It's coming out as a liquid, and then it's coming up through the separate port here for the unit that is in cooling mode. And then you're pushing that liquid through the cool on the indoor unit, and then it's going to come back as a suction gas. So that's how a three pipe system is working when it comes to the indoor unit specifically. When it comes to the outdoor units out here, you're going to have three pipes independent, and the liquid direction depends on whether the outdoor unit is in cooling mode or is in heating mode. So you might hear that called cooling main or heating main, and that is going to depend on the direction of a three pipe system dependent upon the outdoor unit. So on a two pipe system, You're still recovering that waste heat. The process is still the same as it comes down. You're going from hot gas to a liquid where it's in heating mode. You're going from a liquid to suction gas back. The big difference on why you lose some heating capacity is you do not have that independent third line set of hot gas. It's a biphase refrigerant that travels down the in a single pipe from your outdoor unit to your BC controller on a two-pipe method. If you've noticed or had installation questions come up on a two-pipe system, two-pipe systems have to have a drain connection on your BC controller or your MCU. And the reason why that is because those have an additional heat exchanger in there. So that heat exchange process for the simultaneous heat and cooling actually happens. There's a phase change in the BC or MCU controller. On a three-pipe system, we'll go back one, that phase change actually happens in the condensing unit. So you might see that a two-pipe system is required to have a condensate drain connection. And then if you open the actual MCU up, that entire thing is spray foam insulated. So there's a little bit of a difference there for contractors. They have to change a solenoid out. And also they have to take into account the condensate drain lines, which are required because of that phase change that happens within the MCU or the BC controller itself. So that is the big difference on what is the difference between the two-pipe and three-pipe BC or MCU controller is where the heat exchanger is located. So two-pipe method, heat exchanger is located in the BC or MCU. On the three-pipe, that phase change happens actually out in the condensing unit itself. So next we'll take a look at a quick layout, and we're going to look at 40 indoor zones, two systems. Essentially, this is like a large hotel or a large multifamily residence hall. That's kind of what a lot of our industry does, is that hospitality, colleges, retirement homes, multifamily stuff. So wanted to give a good layout of kind of what a contractor's thought process is when they're going about it. And this is a good example to show you on the differences in piping between a two-pipe and three-pipe systems. So for example, here's the layout for a three-pipe system. Now, the next point I want to make is each manufacturer does have some different limits or requirements that you can achieve on a three-pipe system. For example, some manufacturers allow you to pipe your MCUs in series as shown here. Other manufacturers do not allow their MCUs or BC controllers to be piped in series. They have to all be piped individually. And the refrigerant can only go one direction through. So on a three-pipe system, depending on which manufacturer you use, that's where you want to lean on that local support, which Insight and Rod and that internal team are starting to offer in additional to what support they had on originally. And it can allow the contractor a significant decrease in time to get off that project, because that's what the contractor's main goal is when he's there on bid day. Not only is what's the lowest equipment price, but how quickly can I get off that job? Because time is something, if they've got 10 guys out there, that costs a lot of money for them, that labor charge, having to go back. So those are some things that we as manufacturer reps and what Insight thinks about when they're laying designs out. Not only how do I make it work for the owner and what the engineer is asking for, but also what's the best and most efficient, economical way to truly design these products and stay within the manufacturer's guidelines. So for this example, we look at MCUs that are piped in series. And so we would put one at the beginning of the hallway, one at the middle, and one at the end. And that would allow that would be 3 pipes going through the condensing unit to each MCU, but it would then shorten the distances between the 2 pipes from the MCU or the BC controller to those indoor units. So try to give you a little example down here of how it would look, and then kind of imagining up at the top here. So we went through and tallied all these up. So for a 3-pipe system, let's take a look at the piping and materials for this size of a project. 70 feet is what you're going to have between the MCUs. You're going to have an additional 20 feet. Then you've got the 4 5s to each MCU or BC controller on the projects. So we have approximately 330 feet per system of 3 pipes. So that's all 3 of those pipes are going to need 330 feet, and that is hard copper. Then from the 2-pipe sections, you're going to see we have the 35 feet times 4, the 20 times 8, and the 5 feet to all the indoor units, and we have 20 of those located. That's 800 feet per system. So the total for this 3-pipe system is 2,260 feet total. So let's take a look at a 2-pipe system. One clarification I do want to make is it is possible, and this is an example, and this is why this example was put in for this presentation, for a two-pipe system to have three pipes actually involved in that system. So for Mitsubishi or Carrier Media, if they have their main BC at Mitsubishi, for example, can be up to 16 ports. That main BC size does not change whether it's from 5 ports to 16 ports. It is the same size. If they have to add a sub BC downstream, so this is a real example of where a sub BC controller, which you'll see down here, had to be added on this project in order to meet the total number of indoor units. There was 20 total per wing. So they put what is called a sub BC. So the only time on a two-pipe system you're going to see three pipes is when you have a sub BC, and that is going to be three pipes from the main BC to the sub BC controller. So anytime you have a two-pipe system with more than two, that is a sub BC only, you're going to have three pipes from the main BC to that sub BC. Then this is an example to give you that. So I want to make sure to call that out if you were confused, if you saw this three pipe down here. Let's take a look at the piping materials. We're going to look at, and I won't call all these out because there's significantly more. But there, for this system itself, there's actually 3,320 feet of total pipe required for a two-pipe system. So it's 46 more pipe was required for an equivalent two-pipe system, which was the basis of design on this project. So we save over 1,000 feet of copper pipe, which reduces additional installation time. So as you can tell just from this one example, it depends on a two-pipe system might be a better layout versus a three-pipe. It really is in the way that you specifically design it as the engineer, and depending on what rep you're working with specifically. So this is a real-world example that I see a good bit on where three-pipe systems were significantly shorter than two-pipe systems. A lot of the feedback I'll get sometimes, oh, well, that one's only two-pipe, it should be significantly smaller. That's not necessarily the case because that three-pipe is only going from the main condensing unit to your BC controller, your MCU, or BS box, depending on which manufacturer you are using. So we labeled a big four out here essentially with the two-pipe versus three-pipe. So in your far left, you have the two-pipe. So the red right now is giving you the example of two pipes to three pipes. So the far left, that's two pipes, as we discussed, from your condensing unit to your MCU, BC controller, or BS box. And on all three of the right manufacturers, these are layouts you could do with a three-pipe system. So for example, if you wanted to do a single MCU or BS box at every indoor unit shown in example 2 here, you're going to have a significant amount of three pipes on that project by the way that layout is done. If you wanted to go from one to a larger MCU or BS box, you'll see that three pipe is cut down, and even for both the manufacturers on the right. So this just shows you how you make your selection. Sorry about that. Can show that. So, next screen. So the copper pipe varies, as we said. So two pipe uses more line set lead from heat recovery to your indoor unit. Three pipe uses more hard coupler from your outdoor unit to your heat recovery boxes. So your BCs, your MCUs, your BS controllers. So that's the big takeaway here is that you can see the differences between them. And yet it's not just necessarily a two pipe versus three pipe discussion. It's more based off of how those are taken across. On a three pipe system, what contractors think about is this. At every ref net or Y joint, there is a total of 9 brazed joints at the connection point. So you're going to see all of the connection points we bring up here from a two pipe versus three pipe. So there's a significant amount of less brazed joints on a two pipe system than there is on a three pipe system. You see where we have every indoor unit to a single BS or MCU, there's a significant amount of more brazed joints here. And as you use less, or as you make your BC boxes or your MCs larger, such as the 4 ports on this one, you see that the total brazed joints and total joints are significantly less as well. They decrease as you go to the right. This is something the contractor is thinking about because he is out there doing this work. This is letting him get off that project quicker as well. So next we're going to take a look at the equipment footprint. How does that affect the project? So for three pipe systems, they're usually a more common footprint, low profile, lightweight, and a decentralized design approach. And they're smaller from the footprint level is what the main takeaway here would be. For just the breakout on sizes, A 16 port from a 2-pipe system is significantly larger, as you can see, versus a 6-port or a 10 port from other manufacturers. So this has to be taken in consideration when you are going from where you're locating that MCU, BS box, or BC controller. Also, on the 2-pipe system we talked about, you have to have condensate drain lines connected. So when you have this condensate drain lines connected, that also can be dependent on getting those lines over to where you can get rid of that waste water as well. So this is something to take into consideration when you are doing your VRF design on a 2-pipe versus 3-pipe systems. So as we showed on the 3-pipe systems, you do have to have the ref net or wide joints. This can require an additional 6 extra brazes. On a 2-pipe system, you don't have wide joints. You have no wide joints or ref nets. You actually use T's on 2-pipe systems. The wide joints or ref nets are only required on 3-pipe systems. And these are actually installed whether on 3-pipe systems, whether the ref net or wide joints, whether it's a 3-pipe or 2-pipe manufacturer. The wide joints stay for 3-pipe manufacturers on heat pump systems, where on 2-pipe systems, even on heat pump, they use T's versus the ref nets. So they have to be installed 15-degree level, depending on the orientation. There cannot be a change in direction in 20 inches either way. So you have to have 20 inches of straight pipe coming in, 20 inches of straight pipe coming out as well. So these are other design considerations to think, because it takes longer on the install time for the contractor. So we touched on heating capacity. So 3-pipe systems typically have a higher heating capacity than 2-pipe systems. That is because the hot gas line is independent. So you'll see dedicated hot gas line, it produces better heating capabilities throughout the entire operation range. In specific examples, this can be as much as, I think, about 28% capacity gap when your 3-pipe system begins to fully derate. So you'll see a 2-pipe system begins to derate around that 40. A 3-pipe with that hot gas line doesn't begin to derate until about 22 to 24, depending on the manufacturer itself. In our territories, this heating capacity gap is just not that big of a difference because we don't require that. But this is something to keep in mind when designing for that cold temperature areas. And then each manufacturer also has a max heat or a hyperheat product if you do need that additional heating capacity at 0 or even below 0. So we're going to take a look at that application example I was giving. And this is going to be on a 3-pipe system. And this is going to be on a change in pipe length when the project is actually being installed. So this is an example where the contractor thought, hey, I can shorten a specific pipe length, and I can actually take that pipe length and save some money for myself. We're going to see, in fact, how that actually changed the project and actually cost the contractor, had to go rip everything out and reinstall it because of the change. It actually cost them to essentially do the entire project twice. So here's the original layout that you had for the project, and this was secured with. So the under construction, the contractor found a better way to route the piping for this last section of a heat recovery box or a BC controller MCU. So he's thinking less piping, faster installation, that shouldn't make any changes. Well, on 3-pipe systems that are piped in series as this, a line set size change here affects every pipe upstream because it is piped in series. So that is something to also consider when you're piping with a 3-pipe system, is if you do run them in series, a line set change from the last MCU or BC controller, BS box, branch box, can actually affect each line set size upstream of it. Installed per design for the first 3 sections. And so this last one actually went from 45 feet to 30 feet. So we shortened it by just 10 feet. So here is the as-built file that was completed. Let's take a look at what happened. This last 10-foot reduction in pipe, they went from 1/2 inch and 3/8. You'll see now have changed at each size of field to 3/8 and 5/8. So each of these changed upstream. Each pipe size changed just by shortening that last section. So the 10-foot reduction of piping, they installed 1/2 inch, 1/2 inch, 7/8, and then now they need 3/8, 3/4, and 7/8, and then 3/8, 5/8, and 3/4 here. So all of those pipes were installed and run incorrectly just from that shortage downstream. And this is why those as-built designs are so important. If the contractor had not changed that last thing from 45 to 35, we would be looking with a system whose refrigerant flow velocity would not be high enough because the pipe size would have been a little bit too large. So you might have had some heating or cooling capacity issues oil return issues based off of just where this last BS box or MCU was located. So they had to go back and reinstall both sections of those pipes, which cost them additional material labor, and then also a scheduling impact potentially for the entire project itself. So just to wrap up quickly, we will take a look at the 3-pipe versus 2-pipe. You want to look at the design considerations of the layout. Branch controllers, the size, condensate, number of ports, how many you need, the difference, installation differences. Those are things to think about. That 3-pipe systems require RefNet or wide joints, where 2-pipe systems don't. The heating capacity, if that's something to come up, that's also something to take into consideration when choosing between 2 pipes, 3 pipes. And then also those application revisions. And that really requires communication between more of the spec reps, and then also your contractors in the field. But this can be something that engineers might have to deal with on a specific project. If something like this comes up, you might actually see it itself. So does anybody have any specific questions for me before I turn it back over to Insight Partners and allow Rob to bring up the engineering support team that Insight is rolling out? All righty. No questions for me. So what I'm going to do is I'm going to stop sharing.
Hey, Stephen.
Yes, sir.
Sorry, I've actually got one. It's BJ from Asheville. Thanks for putting this together. It's not specific to anything you've covered. It's more of a general question. I know we've had some contractors come through, and you're probably familiar with the Zoom locks. I wasn't familiar if you've come across that or any trepidation, particularly from the manufacturer.
So any manufacturer is not going to give you we don't, from a manufacturer standpoint, as long as it meets our requirements. Going with Zoom lock does not break any warranty purposes for any manufacturer out there. Zoom lock, as long as it's installed correctly using the tools and that contractor's been trained on how to install it correctly. I've seen jobs where that is done 100% correctly, and we have not had any issues in leaks. I've seen jobs where it hasn't been installed correctly, and you had a ton of leaks. On the opposite side of that, I've seen some straight pipe where they didn't use Zoom lock and not installed correctly, and you're just chasing leaks all over the building as well. So one bad installation, and I tell this to every customer, everywhere I'm talking to, a VRF project is only as good as it's installed. And that is why these jobs are important for us as manufacturers rep to be involved in that early design process, as well as those construction meetings that happen before a project is sold. Those are something that I'm involved with, and I press my customers to allow me to attend, because these are things we want to bring up. But from a manufacturer standpoint, it does not affect any warranty. It is whatever that contractor chooses to do, as long as they meet the requirements of what Zoom lock has. But from a manufacturer standpoint, whether they go Zoom lock or not, and I think there's a couple other manufacturers that are out there that do as well. It does not affect any warranty or anything or even from a performance standpoint. What was the feedback you were getting from contractors? Was it just questions about it, or
no,
they have a view one point versus the other?
Well, it wasn't necessarily a particular question. I mean, we of course did the brazing, etc. for it, but they wanted to go with the Zoom lock for a faster installation, more or less. And I mean, we went back and forth. It was a different. It's a project that it may actually be done with construction now, but we essentially got that same response. We went to the manufacturer, and they didn't necessarily take exception to it, but it was all pending on the installation.
And that's those Zoom lock requirements that we talked about. So some contractors have seen and utilized Zoom lock because they can get off the projects quicker, and then I've seen you have some old school contractors that don't want to do Zoom lock at all. Kind of like if you see chilled water piping going towards Victaulic versus just straight welded pipe on from a chilled water standpoint. I've also seen the same thing where some contractors don't want to use soft copper from the MCUs or the BC controller to the ender unit. They want to always use hard copper. So from a manufacturer standpoint, if it's installed correctly, the Zoom lock does work. The fittings, I think the fitting life cycle is within the equipment life cycle. So it's not something that if Zoom lock goes and installs it, you have to worry about that fitting being replaced or changed before the actual life cycle of the equipment either. So that is something I've been asked long term. How does the effect change? When installed, probably those seals should last as long as the equipment lasts. There's a chance for those to leak just like on a hard pipe. But from any manufacturer standpoint, we are not one way or the other versus it. It's very similar with insulation as well. I get an insulation question: what is your minimum requirement? We have a minimum a thickness that we call for, but the different R values and anything else, that's really based upon those local codes or what you're seeing out there, depending on your locality, versus from a manufacturer standpoint. So from us, we don't have an issue of it going zoom lock or the other, and that's how every manufacturer is, to my knowledge. Well, at least with the big five for sure.
Gotcha. Okay, thanks.
You're welcome. Does anybody have any additional questions before I turn this back over? All right, well, thank you guys for coming from my standpoint. I'll be on here as well if any other questions do come up, and we'll turn it back over to Matt and Rod and let them go ahead and roll out a little bit of what some exciting news Insight has been working on.
Thank you, Stephen. It's good stuff.
Thanks, Stephen.
So we have Rod on with us today. Rod is with Insight Partners, and Insight Partners noticed that there was some help needed with VRF systems when it came to layout, installation, a lot of questions. And so we took it upon ourselves to come up with a layout assist program that we want to give you guys a little bit of a taste of today. Rod has joined us. He's going to give us a brief overview of what he can do in the layout process of the project. And we would be happy to meet with you guys individually as an office to get into more details. And Rod can go through actual drawings, an actual project that he's helped on, and show you exactly what he was able to do to help. And with that, I'm going to turn it over to Rod.
Thanks, Matt. My name's Rod Swick. I'm with Insight. I've been with Insight for about 4 years. I have roughly about 200 plus designs under my belt. Prior to that, I was a consulting engineer for about 18 years. What I do for you guys on the support side is I'll be with you from the conceptual stage all the way through the construction stage with the contractor on the project. What we have the ability to do is to provide CAD design or CAD layouts. Samsung has a plugin for AutoCAD, so I can lay the systems out, the equipment, the piping, the controls, the control wiring, and provide the PDF version of that to you, as well as the CAD files if you would like to put those on your drawings, your actual bid drawings. So included in that package, there will also be schedules. We'll provide the tree diagrams for the pipe and equipment. We'll also do the control and control wiring tree diagrams. As part of the package, there'll also be the installation requirements by Samsung. It's a Cliff Note version of what they will experience in knowledge they'll gain inside the install class that I provide. And so I can help with general questions at the beginning. If you provide your loads and a set of plans and some idea of what type of equipment you want to use, I can take it from there and provide you a layout. I've worked on the contractor side. I've worked with the contractor at the very beginning before they put anything in the building or purchased any materials to make sure that the line routing that they actually want to use in the design will work. They basically mark up my plans. They give them back to me. I redraw my plans with their layout and confirm that we're not going to run into any conflicts with the Samsung's piping requirements, and so on and so forth. I've done both on the design side as well as the construction side. I also provide the revisions drawings, and so that we always keep up to date with the most accurate layout that everybody foresees going into the building. As an example, I can show you real quick since we've got a little bit of extra time here. I'll show you my example project here. Okay, so can everyone see that?
Yep.
Okay.
Yes.
All right, so this is just an example of a 7-story hotel that was done in Asheville, North Carolina. And basically you can see that each system, there's different colored indoor units here. So each system is color coded to make it a little easier to follow. In this particular project, I had 3 systems per floor. Got the magenta, the dark blue, and then a dark green system. And this was a heat recovery system, so I have my heat recovery boxes or MCUs out in the hallways. And I've piped them in series. So I have the first one here from the roof drop, connected into this one, and then I connected into the third one. And from there, the individual ports are piped to the indoor unit. So this particular project was a mixture of above ceiling ducted units shown here, as well as vertical air handlers shown here. So I won't go through all. This is really for my presentation that I give separately. We'll go much more in depth, but you know, we'll identify line sizes. You know, here's A and C. That refers to this legend here that correlates the letters to a line size. To help the installers out, I've created details for what the individual MCU boxes, their settings for auto addressing and function and actual pipe configuration. As an example, up on the roof, this is what the layout would look like. Again, much of the same information is provided. Equipment tags, the line sizes, again, as Stephen was saying, for our heat recovery system, 3-phase, and single phase for that matter. From the outdoor unit through the MCU boxes, it's going to be 3 pipes. So we have our liquid suction and a hot gas line. And again, those sizes are listed down here in this legend. So this is an example of what the controls and control wiring diagrams plans would look like. So we have a system loop that goes from the outdoor unit through all the indoor components connected to that outdoor unit. We have a local control layer that goes from basically it's a thermostat to the indoor unit. And then we have a final layer for our central controllers, and basically they connect to the outdoor units and then goes back to the central controller. So all this information is what you'll get both in the CAD and the PDF version of the layouts. Here's an example of the schedules. Indoor equipment is in the gold color, and then the indoor and outdoor equipment is again listed here, and it includes the physical data as well as the electrical data for the indoor and outdoor. Here's a summary materials list. We're gonna, we'll identify the outdoor equipment, how many, the quantities, the sizes, the indoor equipment, the Y branches and the MCU boxes connected to the piping, and then all the accessories. We include the isolation valves, the mini split condensate pumps, as well as some of our equipment. We can add a condensate pump to it. The slim duct units, above ceiling ducted units that we have on this project, the condensate pump is listed as an accessory, so we added those in as well. At the bottom here, we're going to let you know how much pipe is on the project by size. This is for the entire project. So we have about 1.5 miles of half-inch pipe, about 1.25 miles, quarter-inch, so on and so forth. And then we give the total trim charge for the entire project. The outdoor units come pre-charged with refrigerant, but we need to add trim charge in to account for the piping and the MCU boxes in the indoor units. Now, in addition to this, to the design set, I'm also going to give you a report file in Word format, and this will break down this list by system. So it's a little, you know exactly what's going to be on that system. It'll everything from the quantity and size of pipe for that specific system, the accessories, the piping, accessories, indoor and outdoor equipment. Here's an example of the pipe and equipment tree diagrams. The blue line represents 3 pipe, pink line represents 2 pipe. And so we give you all the information. If you've seen a tree diagram before, ours really aren't any different than anybody else's. Have the same basic information: pipe sizes, actual length, equivalent length, number of elbows, indoor capacities, model numbers, ID tags, outdoor equipment, model numbers, capacities, and so on and so forth. In addition to that, we'll give you the tree diagrams for the controls. For those of you not familiar with VRF, the major difference between mini split and VRF is where the EEV valve is located, as well as how the indoor units are powered. So the mini splits, the outdoor unit powers the indoor unit, the EEV valve is in the outdoor unit. For VRF, the EEV is somewhere inside the building. For our system, it's going to be in the indoor unit, and the indoor units are powered separately from the outdoor unit. For a multi-story building, I'll provide elevation, general building elevations. This just helps to give you an idea of what system serves what floor and how it's configured. So this is the piping and equipment elevation. This is the controls and control wiring elevation. And at the very end, I've got these cliff notes. Basically, it's all the big ticket items as far as proper installation for Samsung. Any questions?
You know, I'd like to add something on to what Rod said too. So I've been working in the VRF industry, HVAC industry, since I was 18, but specifically in the VRF side for the last 6 to 7 years. A lot of what we've seen before, didn't matter which manufacturer with it, you see a lot of drawings that are put out where the piping layouts are done. And so what you really get right here is Insight taking ownership of helping you as an engineer ensure that this project is going to be designed and is engineered and installed properly. I mean, when you see the level of detail that is given within these layouts, as far as even the accessories and from the control and power wiring, those are things that you as an engineer are going to be able to lean back and rely on, knowing that Insight is supporting you and this system is going to be installed properly. I've seen some projects in the past where it was laid out with a specific manufacturer. Another manufacturer secured the project, but then that project actually went through a lot of additional design revisions because that manufacturer couldn't meet another manufacturer's piping limits or requirements, because everyone is a little different, right? Everybody says we can do this so many feet, we can do this or that. But in reality, until you put that actual design into a design tool and you make sure that system check is happening, most manufacturers are not going to just lean on just that total pipe length, because that can shorten significantly depending on how many 90 degrees you have, where those units are located. So I really see this as Insight taking ownership to help you guys from an engineering standpoint know that what you're putting out there has been tested, and you're also getting a level of detail that, to be honest, in the Southeast I haven't seen before. from a rep and what they're providing to you as the engineer. And not only that, Rod has my direct number from a manufacturer's rep in the Southeast. So I'm local to Charlotte, North Carolina, but can travel being in any city I need to be. So not only do you have Insight support, but Samsung is here to also support Insight and whatever they need from us as a manufacturer. I'm going to type my email out in the chat. If you are an engineer who needs a PE certificate, please do not hesitate to send me an email or go through your rep. Please copy whoever does cover you, so that person is aware of that you received that certificate from me. But I'm extremely excited to see how this is really, in my opinion, this is going to change the way reps go about it. It's almost similar to like that design assist, even almost like a design build, because of the knowledge Rod brings to the table. And you can be confident in contractors. The feedback we've gotten from contractors on the look is already significant and huge as well. So thank you, Rod, for putting all that all together too.
You're welcome.
All right, guys. I think that wraps it up for us. We appreciate you guys coming. And if you've got any questions, need any more details, would like to get into more specifics with Rod, please contact your local Insight Partners rep. They'd be glad to answer questions, help you guys out. So we appreciate you coming today. We hope this was informative and hope you can see the value that we can add if you bring us in on the layout of projects. So we look forward to working with you guys in the future.